Hello and welcome to this week's 60 Minutes with Scottish Self-Build and Renovation. My name is Gavin Esmond. I'm your host for this evening. Thank you very much for joining us this evening. If you want to just tell us where you're joining us from, it would be great to see that you're from Aberdeen, Inverness, in the UK, maybe you're even overseas. So please just put a wee comment in the comments field and we'll give you a wee shout out during this presentation. So before we do anything else, I just wanted to say that this is being recorded so you can watch it again at your leisure. It's on our YouTube channels and also our Facebook channels. You can also watch this or even listen to this on our podcast channels as well. So we're trying to get with the kids on this one, we're trying to get digital. So if you want to watch this and then you've got anything that you want to query after it, watch it again. And obviously you can get in contact with our guests this week. And of course, this week we are joined by Phil Pumps. We've got Ben Trotter, who is in the background. I'm just going to pass him onto the screen here. So hello, Ben.
Hi there, how are you doing?
Good, thank you. How are you doing?
Very well, very well.
You been up to much this weekend?
No, just enjoying the weather, going for hill walks and eating far too much. But what else are you going to do when it starts to get cold outside? Got to keep warm somehow.
Yeah, I don't know if you're like me. I mean, I enjoy all the seasons, to be honest, but every season's got a plus and a minus. I mean, this season is unbelievably colourful with all the leaves kind of dropping. It's really quite a picturesque type Aberdeenshire. Where have you been this weekend? Have you been far?
Just up to Bennachie. So just lovely forest walk. Like I say, an excuse to come back and work off a bit of energy up the hill, and it's an excuse to come back home and have an enormous roast dinner, which I'm now letting settle. So.
Well, keep your microphone away from your stomach, because
yeah.
No, that's one of the beauties of the dark nights, I suppose. It's good to get indoors, get the fire roaring, and just enjoy a bit of kind of heat. So, thank you very much for joining us. We took a break for the last kind of 2-3 weeks. Actually, I've been on holiday myself. I was in quarantine after, so I've played the game. I've made sure that I'm all safe. And the good thing about doing these things digitally is that you can't catch anything from me at the other side of a screen. But so we've had a little bit of a break. We're back now with obviously Phil Pumps, and this week we're going to be talking about private water supplies.
Yeah, thank you very much as well on behalf of myself and the whole company. Thank you for inviting us to come and get the chance to talk to people about this. I think it's a weird thing. Hopefully part of the presentation will show is that I think there's an awful lot of assumptions with private water in the UK. I think even from like streams and springs and wells, I think a lot of people just assume the water, if it's crystal clear, it's good and healthy and safe to drink. So I certainly hope this opens, not necessarily opens eyes, but leaves people can walk away from this actually being a bit more savvy and aware of the actual practicalities of it's a little bit more complicated than just plug your well into your household and maybe have a filter to take out grit and sand. There's a lot more to it, even in this country.
I think we had a quick chat on Friday, and it's quite interesting how you were saying that quite a number of times in a project, an expert, doesn't have to be Phil Pumps, it could be anyone. So no kind of, it's an interesting area where people should be getting or understanding as quickly as possible in the process and engaging like the architects very early on in the process, and hopefully the architects might reach out to the specialists in the area to say, right, what's going to be achievable with this certain project. So, but you were saying that in quite a number of areas you get engaged a little bit too late in the process, or it's still okay at the end later on in the process, but there's cost to be saved if you're engaged much further on.
So I mean, obviously not to preempt the presentation too much, because we do cover that in a slide at one point. But yes, as odd as it sounds, water pretty much being, it's not just a utility, it's like one of the, that and electricity, you cannot live without them. And yet, surprisingly, all too often, we do get brought in to consult on establishing a water supply or making use of an existing supply. And the house, people are getting told by people, well, we're moving in 2 or 3 weeks, or the house is halfway finished, so we need you to get whatever you're doing finished quickly. We will then get there, and it can be problems such as, well, actually the water supply isn't there's not enough of it there. People will look in a well and see water and therefore assume, oh, if there's water in a well, it must be fine. Or, they'll realize that we can make use of the water, but you need a substantial amount of treatment equipment, perhaps. Or, the presentation covers it a little bit more, but, it's an example that we find too little thought gets put to water, not all the time, but more commonly than you'd think for a major utility. And yeah, it can be solved. It all can be rectified. But again, if you're already X way through the building process, it can be very costly, and it can add delays that you weren't planning for at the beginning of the build, which, it can be a big problem.
I think if anyone takes anything from this presentation, it's really just get involved early. Just understand, get a little bit of understanding from this presentation. It hopefully goes a long way in terms of projects wherever you are in the process. Without further ado, I'm going to blast this onto the full screen. Hopefully it works. If anyone's got any questions as we go through the presentation, it's about 25 minutes long, which is great. Thanks for putting that together in advance. If anyone's got any questions as you're going through the presentation, just pop them into the comments field. There's been already quite a number of comments have been received over the weekend, so we'll run through these at the end of the presentation. So here we go.
Hello, and thank you for joining the presentation today. My name is Ben Trotter, and I'm a technical sales advisor with Philpumps Limited. And the subject of this presentation is private water supplies, with particular focus on their use with domestic and new build properties. We hope by the end of this presentation you have a greater understanding of private water supplies and their use, and in particular how Philpumps can help you develop and utilize almost any form of private water supply. Established in 1992, Philpumps offer almost 3 decades of specialist experience in establishing new water sources or developing and treating existing private supplies, including a variety of wastewater management services. Our knowledge of the practicalities of private water supplies allows us to offer solutions that are in line with all current regulations and legislation, as well as being effective, efficient, requiring minimal maintenance, and offering low costs over the service life of the system. Perfect for any planned new builds on a private water supply. So, as stated, we are experts.
And sorry, I'm going to break into this actually because I've heard there's a little bit of echo coming in. So just give me 2. So, hi Ben. Don't know if you heard that, but I'm just getting a bit of feedback. So what I'm going to do is I'm going to plug myself in. I'm going to plug myself in. We haven't actually had a technical problem yet with anything, so I'm actually been quite lucky with this one.
Because you've never had me on Jonah when it comes to technology.
Let me just go and change my settings. This is all on screen, so this is how difficult it is to do a webinar.
I don't know while you're working at that if it would kind of make use of the time, but if there's any questions asked already that you want me to maybe answer while you're doing the technical side of things.
Yeah, we've had a few actually. Let me just kind of plug this in. So let's just go off script slightly, and I'm going to tackle the first one here. So we actually received this by email because some people are a little bit more shy actually about even putting a comment into a comments feed. So it's our first one is what are the typical costs of a borehole and treatment system? Is that something that's easy to answer?
It's not straightforward, unfortunately, but there are rough figures we can give. So basically, the reason why we can't, and no drilling company will be able to tell you in advance what the cost would be, is because until you start drilling, you don't know how deep you're going to have to drill and how much water you're going to find. So the quantity and quality of the water are unknown until you find it. So we can never say exactly beforehand, this is roughly what it will be. That being said, however, just purely based on, say, like the last 80, 90 boreholes that we've drilled, I would say the average depth that we go to is between 40 and 80 meters. And the average treatment system, again, preempting the presentation when it gets back up and running, The average treatment tends to be for the bedrock in Scotland. Iron and manganese needs to be removed, and the water's a little bit acidic, so we need to treat the pH. And so in total, really, if we were to take like the averages, I would say you could expect to pay somewhere between the £3,500 to £6,000 for the borehole drilling, for the drilling operation itself. And then typical treatment system could be somewhere between sort of like £2,500 and £3,500. The caveats of that being, as we've said, we don't know in advance. It's physically not possible to know how deep we need to drill beforehand. And also it depends on the property. So the treatment equipment is sized based on how much water the property is going to draw through the system. So obviously a little 2-bedroom cottage is not going to need, even if it needs the same things treated in the water as a large property, a little 2-bed cottage is going to have much smaller equipment and therefore lower cost than, you know, again, case in point, we had an email from a building company who's building, you know, like a 8-bedroom property with everything's en suite and an extra facility. So a property like that, even if the water quality is the same, it is going to be more expensive because water is going to get drawn through the system much quicker. So you need bigger vessels so the water has enough contact time with the filters and treatment media. So roughly all in, I would say from having nothing to having a borehole and fully treated water coming through your property, I'd say if you budgeted somewhere between £7,500 to £10,000, that's not a million miles off the mark of what it may end up being.
I guess initial survey information, the more information you can get, even if it's by email, you can probably give a range and then work from that point. I mean, that's probably all you can do at that point because there's so many variables, as you've said.
And obviously, you know, there are records held of other boreholes that might have been drilled in the area. Things like the BGS keep records of boreholes that are drilled. And also just because we drill all over Scotland, we check our own records, and it's particularly in the northeast of Scotland, which is our backyard. It's more than likely we will have drilled a borehole not a million, you know, not dozens of miles away. So we can check that. And while the ground does change, you know, at some point, you know, if you've got a borehole certainly within a couple of miles, you can kind of know what to expect. But yeah, when you're working with nature, it can always be a surprise. So.
Yeah, I guess all kind of self-build or renovation projects must have its curveballs at times, but if you can at least get as much information and start the process, and it makes you a bit more kind of calculated in terms of the success of it as well. So, all right, let's give this another shot. Hopefully it works very well. I think it's maybe because I didn't have myself on mute, so I think that's probably what happened there. All right, we will put this on the screen.
Okay.
Hello, and thank you for joining the presentation today. My name is Ben Trotter, and I'm a technical sales advisor with Phil Pumps Limited. And the subject of this presentation is private water supplies, with particular focus on their use with domestic and new build properties. We hope by the end of this presentation you have a greater understanding of private water supplies and their use, and in particular how Phil Pumps can help you develop and utilize almost any form of private water supply. Established in 1992, Phil Pumps offer almost 3 decades of specialist experience in establishing new water sources or developing and treating existing private supplies, including a variety of wastewater management services. Our knowledge of the practicalities of private water supplies allows us to offer solutions that are in line with all current regulations and legislation, as well as being effective, efficient, requiring minimal maintenance, and offering low costs over the service life of the system. Perfect for any planned new builds on a private water supply. So, as stated, we are experts in the field of private water supplies. We serve almost any industry sector, from domestic, agricultural, small and large-scale wastewater treatment and drainage, commercial and leisure applications. There is literally no aspect of private water supply that we cannot help develop and support. For the purposes of this presentation, however, we will be focusing on the domestic sector, in particular new build projects. However, if you have any questions regarding any other aspect of private water supplies, you can email me at the details shown at the end of the presentation. Before we progress any further, I just want to take a few minutes to discuss the various types of private water supplies and some of their key features. The first and likely most common source of private water is a well. These are very straightforward sources of water, being either a natural or more likely a man-made depression in the earth, then typically reinforced with concrete. Any water flowing through the soil and loose rock can collect in the well, providing a source of water to draw from. They are simple and quick to put in place, but they do have some drawbacks when it comes to reliability. First and foremost being that there is no actual consistency in the quantity and quality of the water supply. Anything that can affect the soil can affect the water. For instance, seasonal weather changes may mean in summer the soil dries and the water flows away rather than pooling in the well. Water can even be lost to evaporation. And in the winter, the ground freezes and can limit the flow of water. Any contaminants that can get into the soil, such as fertilizers and animal waste, can change the water quality. Another common problem is that if another well is made by someone else, perhaps in a neighboring field, then they are drawing from the same reserve of water as you, which can then limit the amount of water your well can provide. Now, don't take this that wells are completely unusable. A lot of wells have provided plentiful supplies of water for many, many years. However, our ever-increasing demands for water is putting traditional water supplies like these under pressure. So when building a new home, if you are going to make use of a well supply, then you need to consider the factors just discussed. This may mean additional infrastructure in order to maximize the best use of the water and to mitigate any potential shortcomings. The second supply is a natural spring. These are points at which water trapped in the bedrock has found a natural fissure in the rock, which lead all the way up to the surface. Like wells, these supplies can be simple to establish, but equally, they also suffer from all of the same factors that can affect water quality and quantity as the water is ultimately flowing up through the loose soil and rock. The third type of private water supply is a borehole. Now, I will be going into a little more detail about boreholes later on in the presentation, but at this point, I will say that while they require more work to establish than wells and springs, borehole supplies offer consistent water quantity and quality year in, year out, regardless of seasonal changes or any of the other factors that affect water in the surface soil. They have even proved to be more reliable than the mains water supply in certain applications. But as stated, we will cover boreholes in more depth later on. The provision of water utilities is a key aspect of any new build. If the water needs of the property are not adequately considered during the planning stages, it can often result in problems once construction has begun. No suitable location in place for necessary water treatment, capacity for additional tanks and pumps not considered, wastewater systems ill-suited to the final needs of the property. These are just some of the many problems we have encountered in our long experience, and they occur more often than you might think. Even things as critical as considering whether the existing water supply on site can meet the demands of the property. This is an especially common problem, particularly with well supplies. It is often assumed that just because there is water in the well, it must be able to supply the water needs of the property, when in fact, upon performing a yield test, it might be discovered that the well water does not refill fast enough. While these problems and others like them can be corrected once building has begun, it can result in costly delays and additional unplanned expense. By consulting fill pumps at the planning stages, we can ensure that all considerations are taken into account, meaning that the build moves on smoothly and with no unforeseen problems. Raw water from private supplies will naturally require treatment. Regardless of how clean it may appear to the eye, it will at the very least require treatment to sterilize any bacteria present. It is very common all over Scotland that water from private supplies will contain contaminants dissolved in the water, such as iron and manganese, as well as the water itself having a low pH level. It is imperative that the concentrations of these contaminants are brought within acceptable levels for the health and safety of those drinking the water, but also for the health of the household piping system itself. For example, elevated iron and manganese in the water will cause blockages in pipes and equipment. This particular type of buildup will be exacerbated further in any hot water systems. If untreated, it can result in expensive replacement of boilers and pipework. Low pH will cause ongoing corrosion to any copper pipework and fittings in the system, which will invariably lead to pipe failures and leaks, as well as the cosmetically unappealing blue staining due to the copper oxide, a byproduct of the continuing corrosion. And this is where Philpump's expertise in water treatment can protect your health and your home plumbing. We can offer a bespoke treatment system for the specific needs of your application, accommodating almost any type and severity of contamination. We use the latest advancements in water treatment and filtration technology to ensure that our installations are efficient and low maintenance, maximizing the operational life of the system and minimizing the potential ongoing maintenance costs. Now, it would take considerable time to detail all the various types of contamination and the various treatment equipment and filtration and how they work in this presentation. However, if there is a specific aspect you would like to know more on, then I will happily elaborate and address any questions after the presentation, or alternatively, you can email me your specific questions on the details provided at the end of this presentation. Our highly skilled engineers can carry out our installation works in a variety of available locations, ensuring a professional finish throughout. As you can see from these photos, however, in some instances, a sizable amount of equipment may be required. Therefore, we would always recommend that before finalizing any plans regarding plant rooms or service enclosures, that you wait to have the quality of the water supply tested so that we can review and advise what expected treatment and therefore what space will be required. Almost every single domestic application on a private water supply will require a pump of some description. Even those applications currently supplied by a gravity feed supply may find that after the installation of a suitable treatment system, the natural resistance of the treatment media and filter membranes diminishes the water pressure so that there is a significant or at least noticeable drop in pressure and flow rate in the property itself. Therefore, a pump will be needed to ensure that the water is pressurized through the treatment system, ensuring that there is no loss of service in the property. There are a range of pumps available, from straightforward surface pumps to submersible pumps that can be placed inside tanks and wells. In terms of domestic applications, one of the most important things is to have a pump that is responsive to the needs of the house and can adapt to the changes in demand. One pump series in particular has distinguished itself above all others in this field, the DAB EasyBox range. With 3 options available for small to medium applications, large applications, and even a submersible option available. This series of pumps has a proven track record of delivering exceptional service for domestic applications. Every aspect of its design has been focused on domestic and home use. For example, the EasyBox range is incredibly quiet. Typical booster pumps may sound like a lawnmower engine going off in your utility or plant room. The EasyBox range has a very low decibel output, being comparable to that of a refrigerator motor going. It is also easy to control with a simple, straightforward control system and display, allowing for much greater use by the customer without the need of having a service engineer out every single time there may be a cause to modify the pump controls. Thirdly, and most importantly, it has an inverter drive. This not only allows the pump to detect when there is a pressure drop in the system and activate, it allows the pump to gauge the level of the pressure drop and respond accordingly. Therefore, whereas typical booster pumps will either be on or off, the EasyBox will raise the amount of energy it uses to meet the live demand. So if there is only one tap active on the system, it will only use as much energy as is required to meet the drop in pressure for that tap. If a washing machine is going, if a toilet is flushing, a shower is going, the EasyBox will monitor the pressure drop and ramp up the pressure accordingly to ensure that all points of use have full pressure and full flow without overexpending energy. By use of this inverter drive, the EasyBox range will typically save you 1/3 on energy bills compared to a comparable booster pump in the same application. If space is limited, we can provide housing solutions to your treatment system requirements. For small to medium-sized equipment systems, we offer a range of secure, weatherproof and insulated kiosks that can be installed outside, freeing up the need for space inside the property. We can also offer a variety of both above and below ground potable water tanks in order to provide a suitable reservoir of water should the water source not be able to meet the demands of the property directly. For larger applications, where significant treatment is required, either due to the quality of the water or the volume required by the application, we can supply and install a combination service room and integrated water tank. These combi tanks are an excellent solution for those projects where there are additional water demands other than the house alone, such as farming. These combi tanks can be sized to the specific needs of the application, with a variety of water tank section and service room sizes available. As mentioned earlier in this presentation, one of the main types of private water supplies is a borehole. These are by far the most superior supplies of water when compared to other sources. They offer consistent, reliable flow, meaning that you need never suffer the ongoing worry day after day of whether you will have enough water, as you might for the other water sources previously discussed. The reason why boreholes are so very good is due to where the water comes from. As you can see from this diagram, there are two reservoirs of water in the ground we can draw from, separated by a layer of impermeable bedrock. Water above this layer is referred to as unconfined, as it is free to flow where it will, as well as being subject to the other factors affecting surface water supplies, which were detailed when we discussed wells and springs earlier on. However, below the initial layer of bedrock, running through fissures and channels of porous rock, are veins of water that cannot escape to the surface and are confined to flow only where the bedrock will allow it. This protects the water from any climatic changes or factors of contamination that frequently affect surface water supplies. The volume of water in these confined aquifers is also far greater than most other private water supplies, with each vein of water being fed in turn by multiple other veins, and so on, fanning out underground across a vast distance. And this is an ongoing, sustainable, natural cycle, providing more water every day than most users would ever come close to using at their property. As mentioned earlier, it does require a little more work to establish a borehole than a well or spring, requiring the use of a borehole drilling rig to drill through the superficial deposits and loose rock down to the trapped water in the bedrock. Using our own drill rig, our professional drill team are able to complete most drilling works in 2 to 3 days, depending on the actual depth to the bedrock and how many veins of water we are aiming to reach. The borehole itself will only be approximately 6 inches diameter at the surface, and once complete, the borehole wellhead is covered and protected by one of our weatherproof and insulated kiosks. Borehole water supplies do vary in quality. The levels of contaminants in the water coming from the differing types of bedrock the water has passed through to that point. So while treatment will still be necessary, the advantage of a borehole is that as the bedrock will never change, neither will the contaminants entering the water. This allows for a consistent quality of water, which in turn allows the treatment system we specify to constantly operate at optimum levels of performance, never having to suffer spikes in water quality, which may make filters and equipment work harder than is necessary. This maximizes the service life of the system and minimizes the ongoing maintenance costs, with some treatment vessels going 2 to 3 years before requiring any major servicing, depending on contaminant levels in the water. Given the protected nature of the water source itself, the reliability of the supply, and the optimum treatment systems we can install around the consistent water quality, boreholes really are the best source of private water, on paper and in practice. At Philpumps, we don't just offer development and support for the incoming water supply, we also offer wastewater management services. With wastewater systems receiving ever more scrutiny from organizations like SEPA in recent years, and the likes of septic tanks beginning to be phased out, it is critical that any wastewater system is well suited for the needs of the property. As distributors for Graph, we have access to their range of wastewater treatment systems, including the highly efficient 1-2 Clean system. What may take multiple treatment tanks to achieve with other systems, the 1-2 Clean can achieve in a single tank. With no mechanical or electrical elements or pumps involved in the wastewater, it is highly energy efficient and suffers less wear than other wastewater systems. It also leaves very little sewage sludge at the end of the process. Now, it might be that the planned new build property is going to have the wastewater connected onto the main sewer line instead. In this instance, we can size up and provide the necessary packaged pumping station to adequately and safely collect and discharge the wastewater into the main sewage network. It is efficient and effective solutions like these which offer maximum service life duration and minimal maintenance costs that we here at Philpumps specialize in. As such, we are ideally suited to size up and specify the required wastewater system for your property. Once any installation work has been carried out, we offer comprehensive service agreements to provide ongoing support during the service life of a system. Each service agreement is tailored to the specific needs of the system in place, ensuring that there are no unnecessary costs involved. The benefits of a service agreement include a dedicated service department offering first-class after-sales support, fully trained service engineers, a dedicated emergency call-out number, preferential hourly labor rates, priority over other non-emergency jobs, and regular servicing organized by Philpumps. So thank you for watching our presentation. I hope you found it informative, and I also hope it highlighted how Philpumps can assist with every stage of establishing and developing a private water supply for either your existing or new build property. We offer complete water solutions so that you have complete peace of mind.
And there we go. I'm just trying to stop the screen. There we go. It must be the holiday. Must be coming back from holiday. I'm kind of all over the place tonight, so apologies for having watching this. Thank you for that presentation. It's actually spurred quite a number of questions from me, but I noticed there was a few questions that had come in that kind of covered that. But I mean, one of the things that kind of springs to mind, obviously, is maintenance. So we're talking about a low maintenance system, but once the system's installed, I'm thinking about the chemicals. I'm thinking about removing the fluids or the waste, if you like, and all the rest of it. So talk to us a little bit about the maintenance of these systems.
So again, it depends on the level of contaminant. So not that we ever really come across really terrible systems. The level of contaminant you've got in your system is going to have some dictation on how often the system needs to be maintenance. If it's particularly difficult water, which to be honest, we only tend to come across if someone's trying to make use of something like loch or river water, which does happen because being particularly open to the elements, they get all sorts of crap in them. So again, a lot of contaminants will mean more regularly serviced treatment systems. But for things like boreholes, even wells and springs, the medias that we use, with the exception of the pH, are all artificial gel medias, and they use natural chemistry and physics to draw the contaminants out of the water. So the first benefit of low maintenance is there is extremely little mechanical or electrical components. So there's less mechanism to go wrong, as it were. So as long as, not being flippant, as long as the laws of physics and chemistry do not change, these treatment systems will continue to work. What you find with, say, like iron and manganese, which highlighted in the presentation as one of the more common types of contamination, is the media will draw out the iron and manganese through a chemical reaction, ion exchange. And then what our engineers do is, depending on the level of iron and manganese contamination, as well as other aspects such as water hardness, they will set a backwash. And this is the only time really you'll have to worry about maintenance, and it is incredibly easy and minimal maintenance. So the backwash system flushes a lot of these filter medias with a brine mix, and that basically just helps flush the media, first of all, if there's any physical clogging in there. And also it actually facilitates a similar reaction to what the treatment medias are doing. And so basically the contaminants, the trapped iron, the trapped manganese will actually jump from the media to the salt ions in the water, in the brine mix, and they get flushed away. That is all automated. The customer never has to worry about setting up the backwash or doing anything themselves. Literally the only thing the customer will need to do is periodically look in the little tank. It's either built into the unit or possibly a separate bucket, and they just have to keep topping up the salt tablets. But again, that might only need to be done once every couple of weeks, maybe once a month. And providing that that little minor bit of maintenance that the customer has to do, topping up the salt, providing they do actually do it, then, for instance, our main iron treatment vessel, which is a little cabinet system with low fouling resin, is very commonly used, and providing the salt is topped up, that could go for about 2 or 3 years before the media needs to be changed and it has a proper overhaul. So yeah, other than topping up salt, very, very low maintenance. pH system is very similar. It's the only one that actually adds something to the water. Every other type of filtration takes an element of the water out. To treat pH, you have to add minerals and compounds to the water that the water is lacking, and that is why it's acidic. So the pH media, again, though, no mechanical, no electronic mechanisms. It's all a natural reaction that allows the water, as it passes through, to naturally absorb these missing compounds and minerals. But because it's adding to the water, it is a consumable. So again, minimal maintenance in that you don't have to touch it at all during operation. But then during the regular servicing, be that once every 6 months, once a year, the media will need changing so that you have fresh pH media in there to add more to the water. So, realistically, it's as minimal as it could. It's as close. What we like to say is it's as close to a set and forget system as possible. I mean, especially if you have, if you go on a service agreement, because then you don't even have to keep a note of when it should next be serviced. Our service team do that. They keep an asset register of all our customers who are on a service agreement. We know what they've got installed, when it should be proactively serviced, because if you don't look after it, the system will start to fail. And then when we do come out to have a look at it, it won't be a case of we'll just give it an inspection, change media, whatever. It'll be a case of, if these systems aren't, if that salt isn't topped up and the backwash doesn't work, the media won't get cleaned and it'll foul, and, it won't last as long. So.
And not all the equipment that's required for this, I mean, it looks quite neat, actually. It doesn't look like it's a huge amount of assets that you have to include in your home. I mean, do most clients have it as a room attached to the house, or could you do something in your garden or submerged in the garden, or?
Yeah, so as we kind of touched on, depending on the level of treatment, if the water, say, is particularly very clean and there's not a great water demand on the property, you could have everything in those little kiosks. And the benefit of that is you could have that remote from the house or just on the outside. What we tend to find is that, again, if you were to take the average treatment system as being pH correction unit, the iron and manganese unit, and of course, something I've not mentioned yet, which is the sterilization, the UV sterilizer. Most people would choose to either have that put on the external wall of the house and they put a lean-to shed on it, or they just have it installed in the garage. It's very, very common for particularly new build properties. If they're planning ahead, the water will normally pass under the garage first and usually then into the kitchen or utility room. So if, as we've mentioned, if you get it at the planning stage, you can actually have it so it comes into the garage. You can have everything bolted to the garage wall. There's plenty of space. That goes a long way towards the weatherproofing. The only thing you have to do then is worry about keeping it insulated. It's a great, garages, sheds, they're a great place to look to install the treatment. And as I said, obviously, if you get really stuck, some people can have them. If it's a bigger new build, they might have a plant room. The only thing I'd say, again, sort of touching on that, is we have done a couple of jobs where, again, if we're not consulted early enough, we will go out to install even a relatively small treatment system. If the water's quite good, it might only need a pH vessel and a UV unit to clean the water. But if we're like one of the last few people there, I've been to jobs where people have already got, the boiler in the plant room. They've got maybe ground source heating or air source heating units in there, other equipment. And it can actually add more complications to the job, because it's not as straightforward as being able to access the water pipe. It's, some of these units will need a power supply. So we'll need access to a plug socket. We will need space in between the equipment to actually route the pipe. So it's definitely very important that if you consult us at the planning stages and you are building a new property, whether you want to go for one of our cabinets or you want to build a nice shed or you want to stick it in the garage or a plant room, if you speak to us from the start, like even if we don't come to install it till near the end of the build, at least you know from the start what space you need and any other requirements that is necessary, other than leaving it till too late and it becomes quite a problem to fix.
Yeah, problem, and I guess additional cost as well. We've had another question come in about multiple properties. I mean, could you have can one borehole? Can I read that? Can one borehole provide water for more than one house?
Yes, in a nutshell. Boreholes can. We've done boreholes that actually will do entire housing estates. So the benefit of a borehole is because, as mentioned in the presentation, it's a regular flow of water and it's a consistent flow. Even if, the borehole per minute isn't able to get the water out the ground to meet the live demands of the property, as long as, you know that in a 24-hour period, the water can provide, say 15, 20,000 litres, then, you can make use of other infrastructure surface such as tanks and then have it boosted out from there to the property. So again, particularly with new builds, water usage is going up and up and up. Even if it's just purely because the utilities that we're installing now, like washing machines and showers and things, they're drawing more water than an older house. So you could actually have a new build 4-bed house compared to a 4-bed house built 20, 30 years ago. They might, on paper, have one bath, one shower, one kitchen sink, utility sink, but the newer build house will actually have a higher water demand than the older house just because of the appliances. So it might be that the borehole can't just be plugged directly into the house, but with a tank and a booster pump, a house is only, even a big house is only going to use maybe about 1,500 litres of water a day maximum. And if you've got a borehole that is, giving you 14, 20,000 litres of water in a 24-hour period, then yeah, you can do 10, 12 houses very easily. So it's not a problem for boreholes at all. As long as we find a viable flow of water, then yes, it can do a lot of houses if need be.
And clearly, I mean, I guess if it's a new build, then ultimately pipe work, etc., that would have to be planned well in advance if you're doing it across more than one house.
Yeah, We have systems in place to ensure that the water is distributed evenly. So again, if you just, you do come to some properties where, especially if it's an old gravity feed system, and one house turns the tap on and then someone else turns the tap on, the water's just naturally physics. It's going to take the path of least resistance first and then back up and then go and fill the other house. So we install pump systems that allow the water to be boosted out from a tank, so that even if all 4 houses are having showers turned on and taps on at once, the water's evenly distributed. So when it comes to piping, it is very important that, again, we're consulted at the beginning, because it could be that, depending on the distance from the water source to the house, to overcome pressure losses, you might need 32 or 50 mil pipe, but it might be the smaller pipe is laid just because perhaps that's what the civils contractors or the plumbers are familiar with. And then when we come to try and, work out how we can deliver water to the property, if the pipe's too small, the amount of pressure the pump's applying could risk splitting the pipe. So it's definitely worthwhile consulting us at the start, just to make sure that pipe is laid correctly and of the right size.
We keep hearing that, don't we? Get involved, get the question in advance. Yeah.
I did notice, I don't know if it was maybe just my computer perhaps, but I noticed when we actually were on the tile 4 planning, the sound kind of cut, but I actually wasn't sure if it was my laptop, but it kind of cut at the point where we did an example of common problems. And so, linked into what you've just been saying, very common problems, even with it, experienced architects say that we've sometimes gone out to sites and like we said, people are very enthusiastic and they crack on with the house build, they get us out and it's like, right, as we've said, you want us to make use of this water source. Well, first of all, have you done a yield test yet on the well or the spring, or even if there's a pre-existing borehole? And if not, it might be that, it just can't provide the water, even in a 24-hour period, particularly with wells. In which case, well, you built this house, you now haven't got a water source. What are you going to do? And again, while, the borehole, like drilling a borehole could be cheap, if someone has to bring in and they've not budgeted for a borehole at the last minute, it is an additional cost. And it is also additional time before it can be finished. Equally, like we said about the equipment, if people don't think of water in advance, they build their lovely house, they might have a little treatment room, but then they say, right, well, we need the water sorted. And then we come in trying to get filter vessels and maybe a booster pump or even a little tank in there. And again, if you've not got space inside the house, well, now you're going to have to go and work out, right, do you need to build a wee shed, or do you need to have another structure in place? So it's quite common. It seems weird, but as we were kind of like discussing before we went live, I have been to a couple of houses where, literally, they've got a move-in date within a couple of weeks, and they believe it's just as simple as, well, we've got the well, let's plug it in. And then we've had our engineer out do the yield test, and it's a case of this well takes 3 hours to recharge half a litre of water once you drain it. And obviously they're then up a gum tree, because they literally, even in 24 hours, there is not enough water there. So obviously that's kind of like a very worst case scenario, but it's happened at least twice in the last couple of years. I've done jobs at Phil Pumps, so it's not something that will never happen.
Mm. And do you find that architects are, they have enough knowledge to be able to explain all this to their clients, or do you think, this is not about architects at all, but I think there might be an opportunity for you guys to speak directly, I guess, to the architect?
Thinking that there could be some architects watching, don't want to impugn the trade. I think it's just the same as everything. You either know or you don't know. And, there's some architects that we've worked with who are very savvy. By the time the new build's ready, it can actually be the architects we're dealing with rather than the customer, because the customers don't necessarily always know about pipe and the design. So they leave that to the architect. And it is also quite common that architects will have, especially things like the waste treatment system, they'll have that spec'd and in the drawing of where it's going to be in the soak away. In some instances, it's because they are particularly experienced, but in others, more recently, one that springs to mind is one we did on the west coast of Scotland. where the architect had specified a wastewater treatment system, but in practice that wasn't going to do the job. Now, the only reason they'd spec that is because they knew roughly we need a wastewater treatment system here, and in a previous job that would, the particular brand or the particular form of wastewater system, it had been done in a previous job, but that was for a little house. This was for a bigger, a much bigger property, and where they were as well, it just wasn't suitable. So again, they had to go back to the drawing board, but it was causing major delay. So I think it is a case of literally, like some architects will be savvy in wastewater, some won't. And it's got nothing to do with attention to detail. I think it's just generally, if they've not had to deal with that side of the water, then it's not something that necessarily gets thought about. I do. It is, one of the biggest hurdles to come across is natural assumptions about water in the UK. Particularly, going back to wells not providing enough water. I think I know that a lot of customers I've gone out to see, they just have had assumptions that, oh, well, there's water and water flows really well here, doesn't it? We're in Scotland, in the UK, even in dry years, we still get a lot of rain, and we don't assume it's like, say Spain or on the continent where you might get a lot of hot weather and water is a lot harder to come by. And the same, that also links in with treatment. A lot of people feel that, well, water doesn't really need treated too much. I mean, if it looks clean, it's not dirty, it should be fine. And as we've touched on, you can have a well. The well might be 10 meters deep and it might be full to the brim, which might give you, and which will give you a false idea of exactly how much water is in there. You think that big deep well, it's full of water, must be brilliant, but until you start drawing that water out, as we said, if it takes hours and hours to recharge a small amount of water, then it's no good. And likewise, if you are using a water source that's quite heavily contaminated, then, it's potentially going to cost more, and, you might need bigger space than you've allowed for on the property. So, yeah, I would definitely, if I could have like one wish, as it were, in the industry, is that kind of everybody thought about water in the same way that they thought about electricity. Because I think people, especially doing this on a computer as an example, I think there's more emphasis that gets put on, right, let's get the electricity supply in first. And I think people just assume, well, water will always be okay.
So that's a kind of indirect question or challenge for anyone watching this. If anyone's had any problems, or even architects, if anyone's looking for a bit of stardom in this webinar, feel free to pop a wee question or comment in the comments field. It's great to understand other people's experiences, because again, this is about sharing other folks' experiences. It could be good and it could be bad about water supply. And it may be something that Phil Pumps can help with. We've got a few other questions, but I'm conscious of the time as well. We've got another 6 minutes. We've got another one here that talks more about planning. It's how long does it typically take for the whole kind of process from install to having water in the house?
So if the client or the customer is ready to kind of move on when at every like milestone, as it were, it can go relatively quickly. So at present, if someone was to say to us right now, book us in for the next available borehole, our drill rig will probably be out there in about three to 4 weeks, due to current scheduling of existing jobs. There's an element of flexibility in that. Obviously, if we're drilling, say, up at I don't know, if we're drilling, say, somewhere near Socken, and the next job we have in the books is down by, kind of like the bottom of the Cairngorms or on the west coast, and then someone else comes and gives us a job, and they're kind of on the other side of Inch maybe, or a Boyne, then we're obviously we're not just going to send the rig all the way to the west coast and then bring it back to a Boyne. We'll do it logistically. So there's an element of flexibility, but I'd say at the moment, to be on the safe side, 3 to 4 weeks for definite to have the drill rig out there. The drilling can be done in only about 2 to 3 days. Once the drilling operation has been finished, usually within about, allowing for engineer availability and pre-book work again, about somewhere between 1 to 2 weeks, we'll have a service engineer back who'll perform a yield test on the borehole and take the water sample. The water sample goes straight to the laboratory, Aberdeen Scientific Laboratory Services in Aberdeen. They're a UCAS accredited laboratory, and we use the same one as the council. And their testing takes, again, approximately 2 to 3 weeks. And as soon as we get those results back in, we can then work on working out exactly what pump you need, exactly what treatment system you need. And then within a day or two of getting those results back, we'll have the quote to the customer. And again, if the customer is happy to go ahead straight away, if they're ready for us, then allowing for engineer availability again, about 3 to 4 weeks. So in total, it could be about the 10 weeks mark from start to finish, with a little variance for things like the lab lead time and, whether the customer is able to get all the civil works done. And again, the brilliant thing about a borehole is you can space things out. So once the borehole's drilled, we cap it and seal it off. Now, if the customer, especially if it's a new build, we might drill a borehole while basically the site is still an empty field or just a vacant plot of land. As long as, no one does anything malicious to the borehole, that borehole will quite happily sit capped off for as long as it takes. So we could do the borehole for you in the spring and come back spring the following year to install the treatment system. And again, because of the consistency of the borehole quality, as we've said, it doesn't matter that we had the water tested last year, it's not going to have changed. Whereas, touching back on the presentation and the problems with wells and springs, if we were to test well water, if we were to use well water test results from a year ago, we wouldn't be comfortable, because there's no guarantee that in the year since the quality hasn't changed. So you can take that breather, you can come back and install a treatment system at a later point, which is handy for a new build, gives physically the house a chance to be built to the stage where there's electricity and there's space for us to install everything. So
is there any kind of planning consents you need to get to drill a borehole or to install? That
would be something that the architects would be best suited to answer on that one. So to my knowledge, no, there's no planning permission to drill a borehole. As long as it's your land and you have permission to drill, you are just drilling a hole in the ground. The only sort of permission that you might possibly need, which is highly unlikely to ever be relevant to anyone building just their own home, is depending on how much water you would be wanting to take out the ground, you might have to notify SEPA, but that's purely from from levels of 10,000 litres a day upwards that you'd be extracting. And as I've said, even like big, huge properties, 5-6 bedroom might only be using 1,800, 2,000 litres a day at a push. So to be using 10,000 litres or more, you are talking about larger scale farms, veering more towards commercial or industrial level. So no. Again, if it's as long as you've got permission to drill on your land, you don't need planning permission, to my knowledge.
I guess, is water available anywhere? Is a borehole available anywhere, or is it dependent on the test?
Again, in a nutshell, yes, we're very fortunate in this part of the world where we live that these underground aquifers are everywhere. Now, some parts of Scotland, or just physically some parts of the land you have available to drill, might yield more water than others, and that's purely because while the diagram didn't quite do it justice, it just showed obviously like the border of rock with almost looked like a pool of water above and below. These fissures or these veins, they run almost like an underground river system, or to quote the water diviner that we use, it's like a tree in reverse. So if you think that the trunk is ideally where you want to drill, and then feeding the trunk is all these branches that then go into twigs, that then go into smaller little twigs. But if all of those, if you imagine, that's all water flowing to the single point. Now, you could drill any one of those branches and get a good supply of water. But the ideal would be, well, if you can drill at a point where they all intersect, and they might be like, above and below each other, there might be 10, 20 meters between each water vein. But if you can drill and hit them all, you maximize the amount of water. Again, like we say, it's just physically no one can guarantee water quality and quantity. You don't know what's down there till you drill. It is a very slim chance that you might get a borehole that yields that can't be used. Again, I would say at the last 90 boreholes we've drilled, I'd say realistically 2 or 3 of them couldn't be used. Of those 3, really only one of them was dry, that had no water in it. The other 2 actually had water supplies in them, and for maybe domestic houses that'd be viable, but they were for larger industrial applications, and they just didn't give, like the 20,000+ liters a day they were looking for. So even to say, that a borehole isn't viable, it's subjective to the needs. Like I say, the average success rate of just drilling is well into the 95-97%.
Very interesting. Absolutely, we've run out of time. It's been actually really eye-opening for me as well. I mean, I don't know much about this water area, so it looks like it's something that's very accessible for most. And if it's a eco-friendly way of being able to service your house, or your group of houses, because I didn't realize you could actually do it to a number of houses at the same time. There's certainly lots of questions that you could be answering people. I mean, if people want to get in touch with you, Ben, how do they do that?
Well, to be honest, the best one would be oh look, there's the details up on the screen. Magic. So the telephone number down there, so Inverurie 623-010, or probably what's best is email, quite simply because I do end up going out of the office on site visits a fair bit. And so ben.trotter@philpumps.co.uk. Obviously, we normally say pop into the office, but obviously with COVID at the moment, while people can come into the trade counter, that's really just to kind of pick stuff up. We can't really, it's not really ideal to have people in for meetings and things. But again, if you have an application, particularly if it's a new build, we can come out to site. There's obviously, providing we follow the current guidelines and our own policies regarding health and safety with coronavirus, we'll do everything we can to make sure that, the customer is as well aware and informed as possible.
We didn't even get a chance to talk about COVID. That was one of my favorite topics, because it's interesting to understand how the whole supply chain has been affected by that. But I think you just said there that you're still coming out to houses in a COVID compliant friendly way.
Yeah, we do, and we're still carrying out installations. Obviously, again, we have, and in the event of a job, we would inform the customer of the guidelines and the restrictions, and obviously they don't come within 2 meters, but we have things in place that we can safely operate at this time without putting either ourselves or the customers at risk. So we're still cracking on, doing as much work as we can, making sure people aren't running out of water.
Great. Thank you very much, Ben. I appreciate that. Hope everyone's going to learn from this. Again, this will be on our social media channels, also our podcast channels. So if you want to pick up on any of the detail, you can watch it again, but you can also kind of obviously email Ben, phone Ben, and the team at Phil Pumps. So thanks, Ben. I really appreciate it. Have a good rest of your Sunday.
Brilliant. Thank you. Thank you for hosting us again. It was nice to have the opportunity to get the word out about the company and what we do.
No, thanks. Thanks again. No worries. And that was Ben Trotter from Phil Pumps. We are back on the 1st of November with Scott Frame, timber kit frame specialists, who will be talking about the benefits of timber kit against traditional forms of construction. Looking forward to that. So that's the 1st of November at 7 o'clock. You can subscribe to our social media channels, Facebook and YouTube, and that'll give you a wee reminder when that is about to start. So thank you everybody for joining. Sorry about the little glitches with our PowerPoint presentations, but we are live, and that's one of the downsides of that. So look forward to seeing you all again on the 1st of November. Take care.